Hello, and welcome to the next edition of Unit 3. This is lesson 3.4, and we're going to be talking about nested for loops in this video. So we already had a kind of example show up in class where we had a nested for loop, and today we're going to really address what nested for loops look like and kind of how many times they're going to run and how they're useful in solving array problems. And they're kind of the backbone, whereas the one for loop, the single for loop, is the backbone for the one-dimensional array. When we get into two-dimensional arrays, the nested for loop is going to be the backbone of a two-dimensional array. So two-dimensional arrays are coming up right after this lesson, and that's how we're going to close out before winter break gets going this year. Is with two-dimensional arrays. So lesson 3.4 is nested for loops. Let's go ahead and get started. Alright, so what is a nested for loop? Well, a nested for loop, just like any nested structure, we use this term to refer to when one thing is inside of another, one control structure is inside of another control structure. We're just putting one for loop inside of another for loop. And there's nothing special about the syntax except that you just need to be mindful of the scope of each loop counter. So, for example, here we've got two for loops, one inside of the other. Our outer for loop is the first for loop that's declared. It's got a variable I for its loop counter. And the inner for loop is the second one, and it's nested. This is the one nested inside of the outer for loop. And I want you to just draw your attention to this. I variable is used up here in the counter in the header for the for loop up here, and the j variable is used in the inner for loop. And the reason why we need a second variable name is because of scope. And that right here, this is the scope of I. And so I is visible inside the inner for loop. And so if we tried to use I as a for loop counter in the inner for loop, it wouldn't work because we already created I, and I exists. And so if you tried to redeclare I, it would give you a compiler error. You can't redeclare the variable twice like that. And so we need to have two different loop counters, and typically people use I and j, but they can be any two different variable names. Okay? So here's our for loop, I equals 1, I less than or equal to 5, I plus plus. And then the inner for loop, j equals 1, j less than or equal to 10, j plus plus. Print out I times j, and then a space. I want you to think, okay, how many times does that print statement get executed? So go ahead and try to think about it, and then when you think you've got the answer, go ahead and hit play. And otherwise, this is the answer. It's going to be 50 times. The reason why the print statement gets executed 50 times is because the inner loop is going to run 10 times every time it runs, and the outer loop is going to run 5 times. So whenever the outer loop runs once, the inner loop runs 10 times, then the outer loop runs once again, and the inner loop runs 10 times. So we're going to have 10 plus 10 plus 10 plus 10 plus 10, which ends up being 50 times, 5 times 10. So we end up multiplying the number of times these loop runs. And you can actually run through this if you need to with the table. I'll just show you real quick the beginning of it. This would be, we're going to need two variables. So we're going to have 3 columns. We have I, j, and then we could have our output, I times j, if we wanted to over here. And so the first time I is equal to 1, and then we enter into the next for loop. J starts at 1, and then we print out I times j, which is equal to 1, and then we update j to 2, print out I times j, which is 2, and then we update 3, 3, 4, 4, 5, 6, 7, 8, 9, 10. This is all with I still equal to 1, because we haven't finished the inner for loop yet. So all of these times it updates, and so we get 5, 6, 7, 8, 9, 10. And then j is done finally. The j loop finishes, and we go println, so we do a carriage return, and then we go to our next value for I, so then it becomes 2. And we run through j again, and so forth. So, with that in mind, what is printed by this nested for loop? Go ahead and think about it for a minute. If you need to, run through that table like I just did, and you should hopefully see the pattern of what's going to happen. If you know the answer already, then go ahead and hit play and see. I'll give you the answer in 3, 2, 1. That would be what would be printed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So all the multiples of 3, all the multiples of 4 up to 40, all the multiples of 5 up to 50. So this gives you kind of a times table, if you will, of 1 times, and then 2 times, and then 3 times, and then 4 times, and so forth. Okay, so that's kind of one use of a nested for loop, is to print out a multiplication table. Go ahead and try writing a program to print out a multiplication table like that. But allow the user to type in how many rows and columns they want. For example, you ask how many rows and how many calls first, and so if the user types in 12 and 12, then you get this nice times table gets displayed where you've got all the numbers, the number of columns at the top, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The number of rows on the left-hand side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on the left-hand side. And then the times table fills out the middle of this, okay? And if you want an added challenge, try to format it so that it looks nice using the printf print format way of outputting. So if you're to use printf, you can get a very nice looking times table this way. And printf, if you're curious again how to use that, you can just Google it, printf Java, and you probably will find some examples. In fact, I bet you can find an example that will do exactly this out there. So yeah, go ahead and give this a try. And in a minute, I'll show you how to get the one on the left. The one on the right isn't that much more difficult. It just involves printf and kind of reordering how you think about some of the problems. So, all right, come back when you've got this thing coded up, and then I'll show you how I went about doing it. Okay, so this is how I did it with a method. I wrote a method for making a multiplication table that takes in 2 variables, rows and columns. And so at the very beginning, we kind of have to handle printing the top of this thing, which, if you remember, was an X vertical line, 1, 2, 3, 4, yada, 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 all the way up to whatever the rows is, or excuse me, calls is. And so you can see that's what this X does, that print there. This loop handles this part of it, 1, 2, 3, 4, all the way up to calls. And then we have a carriage return right here. This is a return, so this is a new line character. Okay, and then the next bit was the dashes across. So there were a bunch of dashes across to separate things. And so this one, there's 2 dashes for the X, and then that one, and then there's 2 dashes for each of these guys. And so this is going to be calls plus 1 dashes. That's how I got all those dashes to print out. And then a println statement, again, for the \n. Oops, this is, that's a /. I meant \n. Okay, so that's just the setup at the top. And then we need to loop over the rows. So for each row, we're going to do some table, right? And then for each, yeah, so we have a row. So our row will start at 1. So that's why our inner for loop, or outer for loop rather, is doing this, start at 1. So it prints the row number followed by a vertical line, and then we do the body of the table. The inner loop is the body of the table. That's going to be I times j plus a space. So that would get you the 1, 2, 3, all the way up to 1 times calls and then we have a carriage return. This carriage return takes us down to the next line. So I updates, and then we'll have 2 vertical line, followed by 2, 4, 6, up to 2 times calls. And then we fill this out. We keep going until we hit rows, vertical line, and this would be rows times 1 times 1. Whoops, 1. Can't spell right now. Rows times 1, followed by rows times 2, all the way to rows times calls. And that's the last entry in the multiplication table. It's going to be whatever rows times calls is. And that's a really good practice for understanding how a nested loop runs, and how you could take some output you're trying to go for and convert that into a nested loop. Again, I want to just reiterate the way we're thinking about this with rows as the outer loop and columns as the inner loop. It's very helpful to think about nested loops this way, because as soon as we get to two-dimensional arrays, that's exactly how we're going to do two-dimensional arrays. Rows and then columns. Rows is the outer loop and columns is the inner loop when we do 2D arrays coming up. Okay, so nested for loops can also be used for some array algorithms. So last class period we had a discussion about how would you kind of take an array and another array and see if one of the arrays was in the other one, and in that case we needed a nested loop to do that. Also, how could you see if one array was actually a sequence of another array or a subarray of another array, and that was also used with a nested for loop. So they're also very common in sorting algorithms. So we're going to look at one particular sorting algorithm, which is called selection sort, which isn't too tough to wrap our heads around. We can wrap our heads around it now. We'll really dive into sorting algorithms in the second semester of this class. But for now, we can just do one or two of them. We'll look at selection sort first. So here's our sorting algorithm for selection sort. For each index in the array, find the smallest element to the right. So we're going to look at all the elements to the right, find the smallest one, and then swap that smallest element with the one that we're looking at currently, with the one at index. So we start at the beginning, we work our way on to the right until we find the smallest element, we perform a swap, and then we go to the next one, look for the smallest element, and then perform a swap, and then we go to the next one, and so forth. And once we've looped over all of these elements in the array, we'll have swapped the smallest one each time to the front, and have our array being sorted. So I want to walk through this again just with a picture so that we can kind of understand what's going on. So we'll start off with this array. 3, 5, -1, A4 is our array at indexes 0, 1, 2, 3, and 4. So it's got 5 elements in it. The idea is we're going to start at 0, find the smallest element in the array, perform a swap, then go to index 1, find the smallest element in the array to the right of that, and then we'll perform a swap, and so forth, okay? And hopefully at the end of doing this, we'll have sorted the array. So the first time we run, we start here at position 0. So we're starting here, and then we look at for the smallest element. So I is 0 to begin with. We look for the smallest element in the array to the right. So we're looking at the smallest element, and we find it at -1 at index 2. So the minimum element is -1, and it's at index 2. So then we perform a swap with the index 2 and index 0. So these guys are going to get swapped. Remember, when we swap, we need to know the indexes that we're changing around. So we just need to know 0 and 2 to make the swap happen. So we do the swap, and these guys get swap rude, and that tells us now -1 is at 0 and 3 is at 2. Okay, so that was one time through the array, or one time through the outer for loop. And in that one time through, we have the smallest element at position 0. So that's good. Now we look at the next position. So now we're looking at 1. So now we're looking at position 1. And we go ahead and find the smallest element to the right of 1. So that would be a 3, right? 3 is our smallest element to the right of 1. So that's min is 3. And the min index of it is 2. So 3 is sitting at the position 2. And so we're going to go ahead and perform a swap right here. We need to know both. We really only need to know the min index actually to perform the swap. We do a swap here. And now we end up with this array, which has 3 at position 1 and 5 now at position 2. And now we have the smallest 2 items, -1 and 3, are both in order. They're at position 0 and 1. Then we do this one more time. So now we look at, now I is 2. We go ahead and look for the smallest element in this piece of the array from 2 onwards. And that ends up being 4. So min is 4, and the min index is 4, because that's where 4 is sitting. And then we perform a swap with position 2. So these guys swap-a-roo. And then we end up with this array down here now. So -1, 3, 4, 8, 5. And so -1, 3, and 4 are in position. And we move on to the next iteration for I. I is equal to 3. So now we're looking at 3. So we're looking here. And we find that 5 is the smallest, so we perform a swap. 3 and 4 get swapped, and so that gives us now 5, 8. Okay, and at this stage we can stop, and we've got our array sorted. But we don't actually have to do the very last index, because when we get to the second to last one, the biggest element's going to be left in the right. Okay. So that's the algorithm. We've got to do a nested for loop to handle this. Okay, so here's our outer loop. Our outer loop will run array.length -1 times. Remember, I said that we don't have to do the very last one. We can cut out one early. We only went through the indexes 0, 1, 2, and 3. We didn't look at 4 because there was nothing to compare after 4. That was the last element. So we can do this array.length -1 times. Assume the one that we're looking at is min to begin with, and then the min index would be the index I, the one that we're looking at. Now here comes the nested loop part. So now we look for each of the guys to its right. So j starts at I plus 1. So we're starting at indexes to the right of I, right? Wherever I is to begin with. We need to look to the right of it. So we start at I plus 1 and then process every element. So we're looking through all the ones to the right. So we get all the way to the end. If array j, that element is smaller than min, this is the typical find the smallest element. We update min to that element and update min index as well, so we can keep track of that index, because remember, we need to know where it is to perform the swap. Once we know where it is, we can make the swap happen. So I do need to have this extra variable here. I need to keep track of the min index, including the min. So this will find the index for the smallest element. So then we perform our swap with the array I and min index. And once we've looped through the whole thing, array.length -1 times, we'll have performed all those swaps and we'd have the array sorted. Fantastic. That's the whole sorting algorithm. We need to have the nested for loop to make this thing work. And in fact, sorting algorithms cannot do things with a single loop. There's an extra loop hiding somewhere around the scenes. There's always some kind of double, you can't just do once over pass of an array to get it to be sorted, typically. So I'm going to go ahead and code this up in IntelliJ and show you how it works, and also a way to make it nice and actually even easier to understand by kind of abstracting out the nested for loop part of it, because I find that to oftentimes be easier to write and to read. So let's go ahead and look at our selection sort algorithm. Here's 3, 5, -1, 8, 4, and here's our selection sort algorithm. For int I equals 0, I less than array.length minus 1, I plus plus. Here's min index. Here's our inner for loop that starts at I plus 1 and goes array.length until the end of the array, finding the smallest element in that subarray and keeping track of it, keeping track of its index, and then once that finds the smallest element and its index, we perform the swap right there. Note I have the helper method swap just behind the scenes to make the code a little bit easier to read. Okay, so let's just see that it works as we intend it to. We run selection sort on the array. So we can see the array initially, 3, 5, -1, 8, 4. And after calling selection sort on the array, our array now is -1, 3, 4, 5, and 8. So it's in sorted order, which is what we wanted it to be, smallest to biggest. Okay. So now I want to show you just real quick how we can kind of take this code here and make it even easier to understand, easier to read. This is pretty clear in the sense that we do have a second for loop going and finding the min index, our index of the smallest that's to the right. We can take this code right here and pull it into its own method. And we can call this method, for example, index of min. And so let's just zoom out just a little bit. Index of min takes an array and an index to look in, and it's going to find the smallest, the index of the smallest element that is from index from and on. Okay? So this second parameter is used to say start looking at from this position and to the right of the array. So it's very similar to this code up here. We basically took all of the stuff that's right here and we put I as a parameter variable. So everywhere we see I gets replaced with from. Oops, this should say, oh no, that's fine. That's perfectly fine. Everywhere there's an I up here becomes from. So we can kind of highlight this, see I. That is now from. And then we have our loop. There's the loop that loops over from +1 to array.length, finding the smallest element and the index of that min from there. So how this is made simpler is now we can just replace all of this code right here with a simple call. We'll just say int min index equals index of min r I. And so now if we read this code, it's significantly simpler to read. We have a for loop that runs over all of the elements except the last one. Min index, which finds the index of the minimum element from I on, and then a swap. And this will work exactly the same as the code we had before. But now we've kind of abstracted, we pulled out some of the complexity of it into a helper method, just like we did for swap. Index of min is a helper method that finds the index of the smallest element in that array. So let's just make sure that this thing still works as we intend it to. And lo and behold, we didn't break it. That's fantastic. And so when we're writing methods that are challenging methods to write, sometimes it's helpful to pull it apart into pieces to solve the smaller sub-problems that are there, such as finding the index of the smallest element in an array, and then combining it back together into one method like we have here for selection sort. So anyway, that's all I wanted to talk about today in this video. Our next video we're going to look at is about two-dimensional arrays, and then how do we loop over 2D arrays, how do we create and access 2D arrays. So it's all in all about two-dimensional arrays, but we needed to talk about nested for loops before we got there. And it's good to still think about nested for loops with the context of 1D arrays, because they do show up quite a bit when doing 1D arrays as well. So I'll see you guys next time when we tackle two-dimensional arrays.